Good morning, ladies and gentlemen. In this video, I would be explaining the analysis of variance. Um, Actually, we are done with the explanation related to t-test, where we usually use the t-test to compare if there are main differences between two uh, populations, two samples. But ANOVA is a powerful statistical tool that is used to compare mean across three or more independent groups. So when the group exceeds two, we know that we have to do ANOVA, which is analysis of variance. In this ANOVA, what it does is to do t-test for all the groups for in pairs. Let's say we have ABC. This it will going to compare the differences and determine if the observed group variations are statistically significant rather than due to random chance. It is used in experimental design, in social sciences and education research, as it were. So the question to ask is that when is the right time to use ANOVA? The first answer is that you use ANOVA when you are comparing three or more groups that are independent. The condition is that the group has to be independent. Number two is that the data, which is the dependent measure, must be uh, in the continuous uh, variable, must be continuous variable. For instance, if it is achievement, is I you know I we have explained in the previous video that continuous are those ones that are in the interval or ratio, where we have, on the other hand, the categorical are those who are either uh, ordinal or nominal. So the categorical variable also, which is the independent variable when we are running ANOVA, must be either ordinal or nominal. For instance, gender. Gender is not suitable. It has to in this part of the world. But it is, we can look at things like, let's say we have a group of students and we want to see whether the marital status of their parents affected their achievements. We have single parents, we have married, we have divorced. So in those three groups, that three group is a nominal categorization. And whenever we are running ANOVA, we always assume that there is normality and homogeneity of variance for valid results. That means that the variations in the group has to be homogeneous. Now, if this is just a theoretical side, we're going to do SPSS video and see what it is all about. But before we do that, the steps in ANOVA, whenever you want to compute ANOVA, is to first enter the data accurately, your raw data. The next thing is to assign groupings, numerical codes to different category of the independent variable. Verify your independent variable uh, with the appropriate label. Then you run your ANOVA. You go to ANOVA on your SPSS, analyze, compare mean, one-way ANOVA. Then you assign the boxes which will be demonstrated as you see it. So while interpreting ANOVA, when the result output comes out, there are uh, four major things to give attention to. Number one is the descriptive. That means the mean, most especially the mean. You can talk about the mean first. Oh, this is bigger than this. This is smaller than the other. And after that, we can now begin to talk about uh, whether the F uh, test is significant, whether there's overall difference. Then you can check the p-value, and also you do a post hoc while necessary. When we did t-test, all that we did was to just use the mean to say this was better than this. But for ANOVA, it may be impossible to make our judgment through the mean alone. So it is important we do a post hoc analysis, which will be giving us the understanding. And there are several post hoc that we could actually use when we want to. We have the Tukey HSD, uh, uh, which has its own assumption. We have Shefe. We have a lot of them. This is just against OL. Choose the test when the assumption of equal variance is violated. When you check the Levene test of significance, you will know whether the assumption of, you know, the significance is actually now, just I have said, the additional information when you know whether the group is different is to know whether uh, the proportion of variance is explained by the independent variable. Let's say it's achieved is a teaching method. The total variance is 100, and the treatment is not the only thing that determines the independent variable. So the eta square, the eta square gives us the information on the amount of variance that our uh, independent variable accounts for. Thank you, and God bless you. My name is Dr. Milani Nathaniel. You could actually check more on the YouTube link for other videos. So in my next video, I'll be demonstrating that which I have explained here with a given data set.